Hello and welcome to another GCSE revision video, and in this video we're going to be practicing what we've learned about vectors. So in this first practice question we're asked to add these two vectors. Okay, good luck with that. Take your time, pause the video. When you're ready with the answer, just press play. Okay, so how did you get on with that? The way to add vectors is simply to join the tail of one vector to the head of the other vector, and then you can draw the vector that represents the sum starting from the tail of the one vector and ending at the head of the other vector. And in component form or column form, depending on how you want to say it, as column vectors, 6 and 12 plus negative 3 and 9. Well, 6 plus negative 3 is 3, because that's the same as 6 minus 3. And 12 plus 9 is 21. Okay, question 2 is asking us to subtract these two vectors. Okay, take your time, pause the video. When you're ready with the answer, just press play. Okay, so how did you get on with that one? Alright, to subtract vectors, we join the tails together and then we join the heads as the vector, and it just matters which way round we're going. In this case we're subtracting the smaller vector from the larger vector, so our vector will have to go from the smaller vector to the larger vector. Remember, what we're doing is we're going to be going backwards through that smaller vector and then the right way through the larger vector. In column form or component form, whichever way you want to call it, 6 minus negative 5, when you subtract a negative, that's the same as adding. So 6 minus negative 5 is the same as 6 plus 5, which is 11. And 8 minus 3 is 5. Okay, in this question we're asked to multiply this vector by the scalar factor of 3. Take your time, pause the video. When you're ready with the answer, just press play. Okay, so how did you get on with that one? Alright, so we're multiplying by 3, so we're not changing direction because it's not negative 3 or anything. So all we're doing is making sure the direction is the same, and we're just making it 3 times bigger. Actually, that's a good way to tell if two vectors are parallel, because if you can take a vector and multiply it by any number that's just a scalar number, then the two vectors are parallel, because it doesn't matter where you actually put the vector. So two vectors would be parallel if you can take one of the vectors and multiply it by a scalar factor, and it'll be identical to the original vector. Now in component form, 3 times negative 3 is negative 9, and 3 times 3 is 9. Okay, then this question is actually lifted from an actual GCSE sample paper. In this question we're asked to work out vector b minus 2a and express it as a column vector. And you'll remember a column vector is the same as in component form. It's in the same shape as the vectors you can see in the question as defining by vector a and vector b. Alright, good luck with that one. Pause the video. When you're ready for the answer, just press play. Okay, how did you get on with that one? Well, we're asked to work out b minus 2a. Well, 2a is vector a multiplied by the scalar factor of 2. So 2 times 3 is 6, and 2 times negative 7 is negative 14. And then b minus 2a then will be b, which is 4, 2, minus 2a, which is 6, negative 14. So that's equal to, well, 4 minus 6 is negative 2, and 2 minus negative 14 is the same as 2 plus 14, which is 16. Okay, and again this question is lifted from an actual sample paper. In triangle ABC, M is the midpoint of AC, N is the point on BC where the ratio of BN to NC is equal to 2 to 3. The line AC is equal to 2 times vector A, and the line AB is equal to 3 times the vector B. And for 3 marks, so we would expect this to take about 3 minutes, work out the line MN in terms of vector A and vector B and give your answer in its simplest form. And part B, which should take a minute, we're told to use your answer to part A to explain why line MN is not parallel to AB. Okay, good luck with that one. Take your time, pause the video. When you're ready for the answer, just press play. Okay, wasn't that a stinker? Well, for me, the difference between staring blankly at the question, not knowing where to go, and making real progress was getting to the point that we can go from M to N by going through from M to A, from A to B, and from B to N. Well, getting from B to N wasn't that difficult because we know that the ratio of BN to NC is in the ratio of 2 to 3. So BN is just 2/5 of the way along BC. The key for me was to realise that BC can be expressed in vector form as a combination of vectors AC, or line AC, which is 2A, and AB, which is 3B. In fact, if we take vector AC and we add to that the negative of AB, then we can get BC. So to get from B to C, we're just going backwards through line AB and then forwards through line AC. So BC, or line BC, is actually negative 3 times vector B plus 2 times vector A. Okay, on re-watching my video, I'm not convinced I explained that quite as well as I could have done. So let me try and visually represent what I was trying to say. The revelation, for me, came the understanding that vector BC is simply negative AB plus AC. That's not a very good straight line, is it? Let's try and draw that a bit straighter. Still not very straight, but there you go. So we're going this way. So this is minus 3B. And this is 2A. So in other words, it's the negative of this plus this. And that for me was the main revelation that allowed me to start making progress. So this distance here is just 2/5 of this whole distance here. The next step was to say that line BN is equal to 2/5, note that the ratio is 2 to 3, so 2/5, because 2 plus 3 is 5, so 2/5 of BC will be BN. So this is 2/5 of BC, and we know BC is -3 times vector B plus 2 times vector A. Okay, and then a fairly easy step was to work out what line MA was, which is just half of line AC, but in the opposite direction, so it's a -1/2 times AC, which is -1/2 times 2 times vector A, which is just negative vector A. And after that it's just explaining that line MN is line MA plus line AB plus line BN. So if we put that in vector form, that's our -A plus 3 times vector B, which we got from our question, plus 2/5 of line BC, so that's 2/5 of -3 times vector B plus 2 times vector A. And then it's just a case of simplifying. So line MN is going to be negative vector A plus 3 times vector B minus 6/5 of vector B plus 4/5 of vector A. Now how did I get 6/5? I multiplied 2 over 5 by -3, and 2 times -3 is -6, so the plus just became a minus. And how I got the 4/5 is just 2/5 of 2, so 2 times 2 is 4, and then divided by 5, and that's all, and that's the scalar multiple of vector A. So I've just expanded out the brackets. Okay, so then it's just a case of combining like terms. So what I've done is I've taken my negative vector A, and to make it easy to combine, I've multiplied top and bottom by 5, so I've made it 5/5 of A, because 5/5 is still one whole, so it's still -A, but it's going to be easier to combine with the 4/5 of vector A. And for my vector 3B, I've multiplied top and bottom by 5, so it's become 3 times 5, which is 15 over 5, so it's 15/5 of vector B. And that's all I've done in that section. So now I've made it easy to combine. -5 over 5 plus 4 over 5 is -1 over 5, and 15 over 5 minus 6 over 5 is 9 over 5. So line MN then becomes -1 over 5 times vector A plus 9 over 5 times vector B, which is our final answer. If you'll excuse my writing that seems to get a little bit bigger as we go to the right. Line MN is not a scalar multiple of line AB, which is how we know they're not parallel. Since there's that vector A quality there, we know since line AB has no A component, there's no vector A, so there's no way we can have a scalar multiple of line AB that will get us line MN. Okay, so how did you get on with that? Okay, if you found this video helpful, don't forget to like so that I know to make more videos like this. Comment if you have any suggestions of other videos that you would like to see me make. That make sure they're GCSE maths related, of course. And don't forget to subscribe and click your notifications on if you want to be told when I upload the videos. Other than that, good luck with your GCSEs, and especially good luck if you're taking them this year, and good luck with your revision, and I look forward to seeing you in another video.